So, last time we had given you guys this worksheet to start on. We didn't really talk about a due date for this or anything, and that's, not a big deal. You guys worked on it a little bit. Maybe some of us made some good progress or maybe some not so good progress. Let's just kind of get an idea of kind of where we're at. So there's basically 4 questions, right? Show of hands, you finished at least 1 question so far? At least 2? At least 3? Finished. Okay, so no, 1 or 2 people have finished then, right? Everybody else has still kind of got some work to do. Okay, so that's fine. So we'll spend a little bit of time today continuing to work on this then. And yeah, that's fine. Before we break off to do that, let's talk about those of you that still have work to do. Is it just like a matter of time that we just need spend some more time with it, or are there things that we're getting hung up on? Or I guess if the things we're getting hung up on, we can probably just talk individually, right? That's probably easier than trying to do this as a group and like me actually just doing the problem, and just be probably better for me to look at what you've done individually and talk about what you're doing. That probably makes more sense. Okay. So let's do this. I'm going to go ahead and take, it'll probably take 20 minutes maybe to do the last piece that I have to do for this chapter here. And I can put that assignment up, so if there are people that are finished with this sheet that need something to work on, they can have a little bit of something to work on. So we'll do that, and then we'll break off and spend the last hour or so just allowing you guys to kind of work and ask questions and that kind of thing. Sound fair? All right. And those of you that are finished, even if you want to come and just kind of check your answers against what I did or whatever and talk about, there should have been at least 1 question on there where you're like, I don't feel like I'm done, but I don't know what else I can do. Yeah. Oh, I don't know. We'll worry about that next week. It's not part of Sunday's homework check. Let's put it that way. Sound good? So we'll worry about that next week, whether it's you just show me what you've done or you come check it in someday before class and just kind of show me what you did, or we put it up there. I don't know. We'll figure out what's going to be easiest for everybody. Sound fair? Okay. And again, the new stuff that we're talking about today obviously isn't going to be part of Sunday's homework check either. So, okay. All right, here we go. So the idea that we're going to talk about today is we're going to talk about how to build out a polynomial that meets certain criteria. And I'm just going to kind of do a couple of examples because there's no new concepts involved. It's just going to be taking the things that we already kind of know and applying them to kind of go in the reverse direction. Okay with that idea? So I'm just going to do some examples here. There's no new concept or anything going on. It's just a different application of things that we've already talked about. Let's see. We'll say polynomial function, just so my vocabulary is consistent. Actually, let's not say that. I'll just do that. Okay. So let's say we want to write a polynomial function with integer coefficients that meets the criteria that it has zeros at -1 that has a multiplicity of 2, 1 minus the square root of 2, and 1 minus 3i all over 5. So what I'm going to do is I'm going to take each one of those zeros and I'm going to turn it into a factor by making a polynomial that's equal to 0. So I'm going to add 1 to both sides. And I'm going to subtract the piece over. And similarly over here, I'm going to subtract that over. Is everybody so far so good? So nothing tricky here. So now what I'm going to do is I'm going to multiply each of these equations together. And since the right-hand side of each of these equations is 0, when I multiply them to 0, or multiply them together, they still give me 0, right? Everybody's okay with that? Now, if I FOIL this thing out, am I going to get integer coefficients for my polynomial? Let's take a look at the factors that we have here. If we try to multiply this all out, am I going to get integer coefficients? No. Why not? Well, I have that square root of 2 rattling around in there, and then I have that 3 over 5i rattling around in there, right? Everybody agree with that part? That those are a problem? So this is how we're going to solve that problem. If you remember, we had the complex conjugates theorem that said we'd be guaranteed rational coefficients if I have also the conjugate for that irrational solution. So I'm going to include this new one. Notice what's different is that the only thing that's different is there's a plus sign in between the square root and the number. Everybody's okay with that idea? And we also have an irrational conjugates theorem. That's going to give me that piece. Again, the same idea, just a different sign in between the real and imaginary part. Everybody okay there? Okay. So now what I'm going to do to make sure that I've done this correctly is I'm going to FOIL those two conjugate pairs out to get a polynomial that's going to have, in the case of the irrational ones, it's going to have at least rational coefficients. I could have to still manipulate it a little bit to make them integer, but it'll at least be rational. And in the case of the complex conjugates, it'll at least give me real coefficients. I might have to still fiddle around a little bit to make that work, but it'll at least do that. Everybody okay so far? Okay. So I'm going to FOIL them out just in the same way they're written. So I'm going to really think about like A and that whole thing as a B when I do my foiling, because it just kind of makes life a little bit easier if I think about it that way. You don't have to. You could do like 3 things to 3 things. That's okay to do too. Just be careful about distributing negatives and stuff when you're doing that. Is everybody okay with what I mean there? If you're not, and I start doing it, you stop me and ask some questions and I'll clarify or talk about what else you could do. But this is the way that I like to do it. So I have x times x gives me x squared. X times negative, let's put that actually out front. 1 plus square root 2. And then I have plus 1 minus root 2 times 1 plus root 2. Everybody okay with how I FOILed that out? Take a minute and look at it. If it doesn't make sense, speak up and we can explain again. I'll draw some arrows and stuff, but should be relatively easy to kind of see what I did there. And now we'll do the same thing to the other piece. Again, I'll pause here and give a chance for everybody to kind of write down. There's a lot of symbols to write there. But again, as you're writing, make sure you understand, like, okay, I see the foiling that you did. Not a big deal. I mean, it's a lot of symbols to kind of keep track of, and that's maybe sometimes the hardest part of it is just keeping track of everything. But it's just, I'm just foiling, right? Now, it's a little weird because one of the things is like a binomial or whatever that I'm foiling with, but it, you know, like, it's still the same thing, right? It's not the first time we've tried to think of a binomial as a single object, right? We do that when we factor by grouping also. Okay, so now I'm going to go back and start cleaning things up a little bit. So I'm going to distribute the negative through and distribute the x through. And same thing. And then this piece is really just the difference of 2 squares, right? Can you guys see that? Where I have like a plus b times a minus b. You guys see that? So I'm going to just use that factoring pattern to shortcut, because really what I get is just 1 squared minus square root 2 squared. And before I move on to the other one, let's clean this all up. So let's see. Those 2 added to give me 0. So I'm left with x squared. I have a minus x, so that's minus 2x, and a 1 minus 2, that's a negative 1. And hey, look at that. I didn't even get rational coefficients. I got integer ones. That's pretty righteous. That's what I was hoping to get. Everybody's okay there? You might end up with a fraction still when you do that, in which case we'll talk about what to do in a second, because it's going to happen on the next one where we're going to end up with a fraction. So you remember how we had, this was our difference of two squares factoring pattern? So that's what I had here, was I had this part. So I just got 1 minus square root 2 squared. And 1 squared is 1, and square root 2 squared is 2.
Yeah.
Is that cool? Okay. So again, if there's a part that I do and I shortcutted through something, you're like, I don't understand the shortcut you took, and it feels like that's important, you're doing the right thing and stopping and asking. We'll go back and like spell it out in more detail. Again, I'll say something, but if it's like, okay, yep, I know I should know that, but I don't right this second, or I don't see it right this second, please stop me and we can do more detail. No big deal. All right. So same thing here. I'm going to go ahead and do that same kind of simplifying. And I'm going to break these up into like fractions because I think it'll make the simplifying here a little bit easier. We have to do in a second. Oops. And again, the last two are a difference of two squares. So it makes it unnecessary to have to FOIL those things out. If you wanted to FOIL them out, you could, but like save yourself the aggravation, you know, man. This problem already gets symbol heavy enough, right? Again, none of the individual steps are that difficult. The concept's not that difficult, but like hanging on to all the symbols to get this to come out correctly can sometimes be a bit of a bear because there's lots of symbols going on. So if I do this, that would be simplifying that piece down. Gets me 2 squared is 4. 3i squared is negative 9i. So 4 minus a negative 9 is positive. And then let's note here that negative 3i over 5 and positive 3i over 5 cancel out. They had an x at the end of those. I forgot to say x. So we have x squared minus 4/5 x plus 13 over 25. Not equal to 0. Holler at me if I need to go back, if I move too quickly. I'm trying to go slow though, you know, but sometimes I still get excited and want to get to the next step. Everybody so far so good? Okay. So if I look, I have integer coefficients here, but not, I still have fractions there. Cool? Everybody see that? Okay. Now if I have fractions there, all I'm going to do is multiply both sides of this equation by some number that's going to get rid of the fractions. What number would that need to be in this case? How about 25? Right? If I multiply both sides by 25, every fraction denominator is, you know, a divisor of 25. So if I multiply both sides by 25, that'll clear out all the denominators and I'll have no problem anymore. Everybody agree with that? Okay, I'm going to erase this here. So I'm going to do 5 onto both sides. Now, notice that the other side is 0, right? So 25 times 0 is just 0 still. So notice I haven't screwed up any of my solutions. that I started with, right? If I still set this thing equal to 0, all the parts equal to 0, I'm still going to get the same solutions that I'm supposed to. Even though I multiplied by 25, it's okay. We see that? Now, does 25 multiply into all of these parentheses? No. It's going to multiply only into one parenthesis, and it can be any one you want. Obviously, which one would we want? The last one, right? And then I would be cool with you guys stopping at this step. When your polynomial has all factors that have integer coefficients, you can be done. I don't need you to FOIL the rest of that thing out, because now it's just tedious and aggravating. Because we know that an integer times an integer gives you another integer, or an integer plus or minus an integer gives you another integer, right? You can't get any coefficients that aren't whole numbers if all your coefficients are whole numbers. Everybody agree with that? So at this point, we've done what we've needed to. I didn't tell you the form needed to be standard form, and I won't, because it's just like multiplying that all out. It's just, it's time consuming. It takes up a lot of space, and it's hard to keep track of everything. Everybody's cool? Okay. So yeah, that's the idea. That's the last concept I wanted to talk about, is just going from a criteria to some kind of polynomial. Okay with that? And this is I would say, a pretty hard example. They don't get substantively more difficult than this. All right, so let's put in that final homework assignment then into Power School. This will be the last homework assignment for this. Well, there'll be a review still. But other than the chapter review, this will be the last homework assignment for this chapter. So we're probably looking, I'd like to do the chapter 5 test before break, right? I think the earliest I would schedule it is for that asynchronous day, which is Friday and Monday the following week. That would be the earliest day I would want to do the test, is just having you guys do it at home or whatever. Especially because this stuff, it can tend to be kind of time consuming, so we can maybe make a bigger block of time than 80 minutes. If you're having a problem getting the synthetic division to work out, that can be time consuming, like sorting through what your problem is and all that kind of stuff. So might be easiest to try to do it on that day. So just as a heads up, that's what I'm kind of looking at. We'll set that in stone though next week on Tuesday or whatever, but that's kind of what I would be planning for, if that helps. And is that usually going to be easier for you guys on an asynchronous day to find like a 2-hour block to do it, even if it has to be the same 2-hour block for everybody? This is the way I'd like to do it. Just, set some block of time, and we're all going to take it during this block of time. That would be okay in general to do, because nobody has scheduled class hours, right, on those asynchronous days. Okay. And I'm not a jerk for trying to do that, right? If I wanted to try to do it that way, nobody's going to be mad about that. Okay. I just want to make sure, because if you have issues with me trying to do that, I don't want to do something that's really kind of a pain in the butt, and it makes things really difficult for me, and it's kind of unfair. I don't want to, we can always do it in school. It's not that big of a deal. It just felt like it might be easier for me, because I get it done in one day, kind of, we can give you more time than maybe it would. I don't have to be quite so discerning about, I'd have to be very careful about the length of this test, because there's a lot of things that can be kind of time consuming. And I wouldn't want to run into a situation where we've taken more time, the test took way longer than I expected, kind of thing. And so I don't want to run into that situation. All right. Okay, so any final questions about any of, yes, Eddie?
Can you show how you FOIL X minus
Yeah, yes. One quick second. I just want to pull up this last homework assignment and get it in there before I forget to do it. But yes, we can go back and do that for sure. So the way that I did that, well, let's do a different color, right? That's probably a bad color to use. I did x times x, that gave me the x squared. Then I did x fraction, and then I did that fraction times x, and then that fraction times that fraction. Is that okay?
Yeah.
Okay. So again, I just tried to think about it as really as simply as I could, just as like an a plus b and an a minus, you know, like, or an a plus b times an a plus b, or an a minus b, I guess, in this case. Does that feel okay?
Thank you.
Yeah, no problem. So I'm gonna, again, I didn't have this thing quite formatted correctly, this final homework assignment. So I'm gonna do that and drop it in there. But you guys can start working your packet from last time if you still have things to work on there.